Okay, so for the last part, we'll be dealing with absolute value equation. So just a brief recall out here. Absolute value just turns everything to positive, basically. So if we have your absolute value of 2, that would just be 2. Absolute value of -2, that would be 2. Turn everything to positive. So given that fact, how do we solve this equation out here? So for the first one, we have the absolute value of 7 minus 2y equal to 9. So to solve this one, take note that this equation means that this one is either equal to 9 or it can also be equal to -9. Since if this is -9, taking the absolute value, we still get this. This means that we'll have two cases. So case 1 again, if 7 minus 2y equal to 9. And then let's just solve this standardly like a linear equation, since it is a linear equation. So we move this to the right side, so we'll subtract 7 both sides. That just means that we have here 2y equal to 2. And then we divide -2 both sides to obtain y equal to -1. So quick check, if we plug in -1 out here, this one will become -2 times -1, that would be 2 plus 7, give you an. And then case 2. Let's have here 7 minus 2y equal to -9, right? So in this case, we do the same thing. We move this to the other side, so we'll have -2y equal to -9 minus 7, that is -16. Then afterwards, we divide -2 both sides, and that will give us y equal to 8. Again, you can easily check 2 times 8 out here 16, so 7 minus 16, that's -9 equal to 9 when you take the absolute value. That means that the answer for this one is either y equal to -1 or y equal to 8. Or there you go. And then for this next one, we have here absolute value of 2x plus 1 over absolute value of 2x plus 1 over x minus 1 equal to 3. Apply the same game, so we have here case 1. We have here 2x plus 1 all over x minus 1 to be equal to 3. In here, the natural or the standard way is to move this to the other side and then combine them into a single fraction. But you can also just multiply x minus 1 both sides, provided, so let's do that first one. So let's multiply x minus 1 both sides, that will give us this one, provided that we won't consider that this is true whenever x is equal to 1. So in this scenario, we must assume that x is not equal to 1. Basically, when we arrive at an answer, if it is equal to 1, then we don't consider it. If it is not equal to 1, then we can consider it. Good, so simplifying, this is 2x plus 1 equal to 3x minus 3. Let's move. This one goes here and this one goes here. So we'll be left with x equal to 4. So I hope you were able to follow that. And then observe here that since x equal to 4 and it's not equal to 1, then this must be true. Good, then case 2. For case 2, there we go. So case 2, we have 2x plus 1 all over x minus 1, this time equal to -3. So we do the same thing. We multiply x minus 1 both sides, so we have 2x plus 1 equal to -3 times x minus 1, again provided the fact that we don't consider this when x is equal to 1. Then let's simplify. So we have here 2x plus 1 equal to -3x plus 3. Then move this to the left side, so we obtain 2x plus 3x, that's 5x equal to, move this to the right side, so we get 3 minus 1, that is 2. Then divide 5 both sides and we obtain x equal to 2 over 5. And you can easily check that these two are correct, so we can conclude that the answer for this problem is x equals 4 or x equal to 2 over 5. Let's just put this out here. Let's put an or. Okay. Good. Yeah, so that's pretty straightforward. Let's move on to this next one. Now in here, instead of doing some cases, a nice trick that you can do here is to square both sides. So take note that when you square both sides, we can omit the absolute value sign since we are already dealing with positive things out here. And then from here, you might be tempted to expand these two. That will lead you to a problematic one. What a good trick out here is to move this to the left side. So what I mean by that is we'll have here x minus 4 squared minus 5 minus 2x squared equal to 0. And what do you notice here? Well, we have a difference of 2 squares. So we have here this one, if you can view it as a squared, this one minus b squared. So we know that that thing just factors into. So we'll have here x minus 4 minus 5 minus 2x times x minus 4 plus 5 minus 2x. Got that one? So basically this is like a minus b, and then this one is a plus b. So take note that when you do the cases technique, you will have two cases, and basically these two factors out here covers that cases. Okay, then for this to be true, again, either this one is equal to 0 or this one is equal to 0. So for this first one, let's just simplify this one. Take note that the first one simplifies to x minus 4 minus 5 plus 2x, or when simplified, that is 3x minus 9. Right? Yep. And then for this next one, let's just sum. So we just combine what we can combine, and so we'll be left with, let's see, this is 1 minus x equal to 0. Okay, good. I think that one is correct. Yep. And then let's just simplify. By that I mean, if the first one is 0, so we have 3x minus 9 equals 0, or 1 minus x equals 0. If the first one is 0, take note that we just move this to the other side, so we'll have 3x equals 9, divide both sides by 3, and we get 3. And then for this one, obviously this is true if x equal to 1. And yeah, that's basically the answer for this one. You can easily verify that this is true. Pretty nice. So you could opt for that method, but if you prefer the cases method, then there's no harm in that one. Anyways, you'll still get the same answer. Okay, then for the fourth item in this part, we have your 3t minus 2 equals negative t squared. Before you do some acrobatics out here, take note that t squared out here is always non-negative, right? You multiply in negative out here. This means that this value will always be negative. Or it can also be 0 or negative. But take note that if we consider the case that it is 0, so if negative t squared equals 0, then that just means that t equals 0. But obviously, t equals 0, this one will become 0, this one is negative 2. Take its absolute value, that will be 2. But this one is not equal to 2. So, not a solution. So that means that this thing cannot be 0, which leads us to the fact that it can only be negative. But take note that absolute value is never negative. It will always be positive or 0. But since we have shown that it cannot be 0, take note that we can conclude here that, let's see, the equation does not have any solutions. I don't know why I did it in this form, but yeah, solutions. So let me put here a y so that you can take note why, in fact, that this one has no solutions. Again, the explanation is because this one is... Okay, good. So yeah, let's move on to the fifth item, or the 20th item in this bunch of videos. So we have your absolute value of 3x plus 8 equal to x. You can do the cases method or you can do the squaring method. I'll do the squaring method. So we'll have here 3x plus 8 square equal to x squared. Then again, this will be equal to 3x plus 8 squared minus x squared equal to 0. And then difference of two squares. This factors into 3x plus 8 minus x, as well as 3x plus 8 plus x equal to 0. And then from here, let's just simplify this one. We'll obtain on the first one 2x plus 8. And then on the second one, we will obtain 4x plus 8. Then take note that this just means that either 2x plus 8 is equal to 0 or 4x plus 8 is equal to 0. Solving for the first one, take note that to move this here, we'll obtain 2x equal to negative 8, divide 2 both sides, and we'll get x to be equal to negative 4. Or, on the other hand, if we move negative 8 out here, so we'll have 4x equal to negative 8, divide both sides by 4, and we'll be left with x to be equal to negative 2. Are we done? We check first, right? Okay, so let's move this out here. Take note that in here, if we take x equal to negative 4, then this will be negative 4. If we take x to be equal to negative 2, then this one will be negative 2. So what am I pointing out here? If we take any of these two, we'll get a negative value out here. But then again, like in the previous item, absolute value cannot have an output into a negative. It must always be positive, which means that neither of these two will actually be a valid solution for this one, which means that we can conclude that, let's use red so that we emphasize it, which means that we can conclude that there is no solution in this problem. Let me put here again a y so that you can remember what absolute values mean. So yeah, so that's quite sad that we don't have solution so far. But let's see on the last item. So we have here the last item, basically the same as the previous item, but this one, it's negative. So how do we do this one? Take note that you can check that the solution will actually just be the same as the previous item. So let's copy that one. And let's see what will be the differences. The differences here will just be this one, negative x squared. But negative x squared out here is simply just equal to x squared, right? So we'll still get this one. So basically this one is just a different step. Let me highlight that one down. This one will only be the different step out here. Other than that, everything will flow smoothly like the previous one, and we'll end up out here. But this time, observe that if we plug in x equal to negative 4 out here, we'll get a value that is positive out here. And in fact, you can check that if you plug in negative 4 out here. So let's see, this one becomes negative 4. So we have 3 times negative 4 plus 8, that is negative 12 plus 8, that is negative 4. Take the absolute value, you get 4. So these two will be the same. So this one is actually a correct value out here. How about for the x equal to negative 2? If it is negative 2, then this one will become negative times negative 2, which is 2. And that one is positive. So if we replace this one with negative 2 this time, so we'll have 3 times negative 2 plus 8, that is negative 6 plus 8, and that would be 2. So this one would also be correct. So x equal to negative 2 will actually be a solution to this one. So as you can see, the solution that we obtained earlier, it's not a solution if this is the case. But if we add negative out here, this one will already be a solution. So that is the nice thing about absolute value. It's quite tricky. You need to remember the signs and you always need to check. So I hope you enjoyed that one. So that marks the end of our equations series. So again, we went over polynomial and rational equations. Then we went over radical equations, quadratic form equations, absolute value equations, and yeah. So I hope by this videos, your grasp in equations is now strengthened, because next time we'll be dealing with tougher opponents like inequalities. If you have any questions, concerns, or constructive criticisms, feel free to comment it down below. Besides that, have a great day.